Okay, welcome back, ladies and gentlemen. Unit 2, Operations on Radicals. This is Lesson 1, Adding and Subtracting Radicals. If you remember from last unit, we actually cannot just simply add the radicals by adding their radicands. Okay? That cannot be done. Okay? If you remember from last unit, that's what we did cover. But in this unit, we can come up with some rules in which we can do some addition and subtraction of radicals. And this first investigation. Now, investigations via YouTube videos are going to be a little bit tricky. So if we look at this little investigation, it says use a calculator to investigate. Where's my highlighter? Use a calculator to investigate which of the following radical statements are true. So of these 5 statements, which ones are true? It says circle statements which are true and place a single line through the expressions which are false. So in your calculator, you should be able to plug in these values, square root of 2 plus 5 square root 2, and get some kind of decimal number, and then do 6 square root of 2 and see if those are equal. And you do that same process for all 5 of those, and then you'll be able to determine which ones are true and which ones are not true. So you should pause the video right here for a minute or two while you quickly do those in your calculator, and then resume the video when you are ready. So now that you've done the investigation, let's figure out which ones of these were true or not true. Number 1, or Roman numeral 1, this is true. Number 2 is also true. Number 3 is true. Number 4 is not true. And number 5 is not true. So you should have been able to come up with those. Now, question B says, use those results to suggest a rule for adding and subtracting radicals. So the 3 on the left-hand side, these are true. And then the 2 on the right-hand side are not true. So what would a rule be that makes all of these true, yet makes all of these false? And it might not just be one rule as opposed to a combination of a couple of things. Hopefully you're able to see that if we have the same index, so here all of these are 2, 2, 2, 2, 3, 3, 3, 2, 2, 2. That makes that possible. But on top of that, remember over here in number 5, these indices are also the same, but this becomes false. So what other part of the rule is going to still keep number 1, 2, and 3 true, but make number 4 and 5 false? It also has to do with the radicand. Same radicand. And if you remember, the radicand is the thing inside the root sign. So here you can see in number 1, the index is 2 for all 3 of those, and the radicand is 2 for all 3 of those. In number 2, the index is 3, and the radicand is 5. Number 3, the index is 2, and the radicand is 8. So that has to be the case. So over here, I'd already mentioned, number 5, the index is 3, which is the same, but the radicands are different. That makes it not possible. Cannot simplify this. And for question number 4, well, the radicands are the same, but the indexes are different. Okay, so that makes that not doable. Okay? So the rule is that we can add and subtract radicals based on the index of the radicals and based on the radicand. Has to have the same index, has to have the same radicand. Question C. Simplify and express your answer as a mixed radical. 8 root 7 take away 3 root 7 plus 15 root 7. So first check the indices. The index is all 2 for all 3 of those, and the radicand is all 7. So I know I'm going to end up with an answer with square root 7. And then I just simplify the coefficients. 8 take away 3 is 5 plus 15, 20. Number 2, 18 fifth root of 10 plus 12 fifth root of 10 minus 7 fifth root of 10. Well, that's all the fifth root, so that's good. The indices are the same, and they all have the same radicand, which is the same. So I know my answer is going to have an index of 5 and a radicand of 10, and I simplify the coefficients. 18 plus 12 is 20, 30, minus 7, 23. 23 fifth root 10. And number 3, 5 square root x, take away 4 square root x. Well, the index is both 2. The radicand is both x, so I know that my answer is going to have square root x, and I just simplify. 5 take away 4 is technically 1. If you wrote in the 1, I would not take a mark off, but we generally don't. Generally, you'll just see square root of x. It's just like seeing a lone variable by itself. We never really write the 1 that's in front of it, but it's there, right? It's implied. Investigation number 2. Use a calculator to verify if the following statements are true. Does this appear to contradict your rule in question 1b? So is this true? Does the square root of 2 by decimal plus the square root of 8 by decimal equal 3 times the square root of 2? And the answer to this is true. Actually, sorry, I should have given you time. I forgot to pause the video or pause and give you time to do that. But that is true. Question 2, 5 square root 12 plus 6 square root 48 is equal to 34 square root 3. Here I am going to give you a minute to try that out and see what you come up with. So by now, you should probably have figured out that those both work out and those are both true. But what is the problem with question B? It says, does this appear to contradict the rule you wrote in investigation 1b? Well, if we look at number 1, this radicand and this radicand are not the same. So how can I combine those to get this? Number 2, this radicand and this radicand are both not the same. And how can they combine to give a completely different radicand? Well, the answer comes from simplifying the radicals as you work through. And this is no different than, here, let me show you a question of a topic that all students hate. 3 over 7 plus 2 over 4. That should be a plus, not an and. Any kind of fraction work always throws students for a loop. But the first step in this question, even prior to creating your common denominator, would be to simplify and reduce this fraction, because it's always easier to work with smaller numbers, smaller fractions, smaller radicals, than it is to work with bigger ones. So I would simplify that to 3 over 7 plus 1 over 2. This idea of simplifying 2 over 4 to 1 over 2 is no different than when we try to add and subtract radicals together that aren't simplified. The best thing we can do is simplify them to begin with and see how things combine. So if we look at question C, 2 plus the square root of 8 is also equal to, and if you remember how to simplify radicals, then this would also be equal to square root of 4 times the square root of 2, and the square root of 4 is equal to just a 2, so plus 2 root 2. And now you can see that the radicands are the same and the indices are the same. This would be a 1 plus 2 is 3 square root 2. So we always have to try and simplify our radicals before we do any processes with them. And you always have to make sure that your radicals are simplified in a final answer. So it's always a good habit to get into. Question 2, 5 square root 12 plus 6 square root 48. I'll do 5 square root 12 using prime factorization, and then I'll do 6 square root 48 using your knowledge of perfect squares. So 12 breaks down into 2 times 6, which breaks down into 2 times 3. So this is 5 square root 2 times 2 times 3. And because it's square root, I look for groups of 2. So this 2 is going to come out of my radical. It's going to pop out. And I'm going to be left with my lonely 3. And I'm going to multiply these coefficients together. So this is going to give me 10 square root 3. 16 square root 48. Well, if you know stuff about your perfect squares, I know that this is 16 times 3. So I know that 16 is a perfect square. So this is 6 square root 16. Ooh, that's so messy. 6 square root 16 times square root 3. which is 6 times square root of 16 is 4 times square root 3, which is 24 square root 3. And I'm simply adding those together. Now you can see I have the same radicand, the same index, 34 square root 3. So you always have to simplify and simplify your radicals before you do any work with them. We go over the page, adding and subtracting radicals. Kind of just went over all of this. In order to add or subtract radicals, they must be able to be expressed as like radicals, which means that radicand is the same and the index is the same. And if you can't make them like, then you can't combine them. That's not saying that some answers are going to have more than one term in it, because that's possible. That's no different than saying, hey, what's 2x plus 3x plus 5y? I can combine the 2x and the 3x to get 5x, but I can't combine that 5y with anything, so it just stays there by itself. I can do the same kind of thing with radicals. Now let me erase this, so I've got some space. Okay, so let's look at example. Class example 1, letter A. First step, we need to simplify all our radicals, and whichever process works for you. If you understand how to do the prime factorization method, or if you know what perfect squares to be looking for, whatever is going to get you down, or going to get you to the place where you can find the simplest radical for each of the ones that you're going to deal with. Okay. Square root 80, I know that 80 is equal to 2 times 2 times 2 times 2 times 5. Because it's square root, I look for groups of 2. There's 2 groups of 2's. So this 2 is going to come out. This 2 is going to come out. And I'm going to be left with my lonely 5. So square root 80 simplifies to 4 square root 5. Do a similar process with 20. 20 is 4 times 5. So that's the square root of 4 times the square root of 5. Square root of 4 is 2, so this is 2 square root 5. So now I'm subtracting 2 square root 5. This is like apples and apples and oranges, right? The square root 5 stays there. 4 take away 2, 2 square root 5. Unless you're dividing, you cannot get rid of that radical symbol. It's going to stay there somehow. Question B, cube root of 80 plus the cube root of 270. Well, the roots are the same, or the indexes are the same, indices are the same, so I can combine these, provided that I can make these radicands look the same. So of course I need to simplify them. Square root 80 breaks down into, we already did it, 2 times 2 times 2 times 2 times 10. I'm looking for cube roots, so I look for groups of 3. There's one group of 3. That 2 pops out. And I'm left with, oh, not 10, that shouldn't be a 10, that's a 5. 5. And I'm left with 2 times 5, which is 10. 270 breaks down into 3 and 90, 3 and 30, 3 and 10, 2 and 5. There's my group of 3. So that's going to give me 3. And I'm left with my 2 times 5, square root 10. Same radicand, same index. Actually, this is technically wrong because these need to be 3's. It's cube root. So this is going to be 2 plus 3 is 5, cube root 10. Now, I'm going to give you a minute. I want you to attempt to try and do this one. You pause the video, work through, and then when you come back, my next screen is actually going to show the full solution, and I'll just talk through it. So hopefully you were able to simplify your radicals so that you came up with 21 square root 3, which comes from 27 being 3 times 3 times 3, which gives me 3 root 3 times the 7 that was already there, 21 square root 3. And then 75 is 25 times 3. So I did this one in knowledge that 25 was a perfect square. So this is going to give me 25 times 3. So square root 25 times square root 3. Well, square root of 25 is 5. 5 times the original 3 that was there is 15 square root 3. Get rid of those lines. and then square root 147. A little bit tougher for this one. This one is 7 times 7, which is 49 times 3 is 147. So this 2 7s make a pair. That's one group that comes out of our radical sign. 2 times 7 on the outside now is 14 with a square root 3. You can see that they all have the same radicand. They all have the same index. So I simply combine. I'm going to be left with square root 3. 21 take away 15 is 6 plus 4 is 20. Square root 3. Hopefully you were able to get that far. Moving on, if we look at example 2, where's my hand? There we go. Example number 2. Simplify by combining like radicals. Now, both of these questions, fairly high-end simplification of radicals questions, mainly because they do deal with fractions, but it's nothing that you shouldn't be able to deal with, okay? Nothing at all. And then let me just have a quick look ahead to number 3, okay. So -5 square root 108 plus 3/4 square root 8 minus 5/4 square root 48 plus 1/2 square root 50. Well, the 8 and the 48 and the 50, I can see those are going to simplify fairly easily, but the 108, that might be our tricky one. So you can do this work right here in the question, or you could do this work somewhere else. 108 breaks down into 2 times 54, which is 2 times 27, which is 3 times 3 times 3. So 108 is 2 times 2 times 2 times, sorry, not 2 times 2 times 2, it's 2 times 2 times 3 times 3 times 3. And if I'm doing square root, that 2 is going to pop out, that 2 is going to pop out. I'm going to be left with a 3. So this would be 6 square root 3. Multiply by the original -5 that's there. -5 times 6 square root 3 is -30 square root 3. And then I simplify the rest. Square root 8, hopefully pretty soon you get to a point where you're very quickly simplifying these. Square root 8 is going to be 2 times 2 times 2, which is 2 square root 2. So now I have 3 over 4 times 2 square root 2, and we make this into a fraction. Any number, no matter what it is, can be made into a fraction. And when we're multiplying, we simply multiply straight across the top, straight across the bottom. There's purple. Okay. 2 times 3 is 6 over 4. 6 over 4 square root 2. Well, 6 over 4 square root 2 simplifies to 3 over 2 square root 2. So we're going to combine this. We're going to combine this. We're going to keep simplifying. 5 over 4 square root 48. Sorry, I got interrupted. I think we were at 5 over 4 square root 48. So somewhere you can simplify 48. 48 is going to be 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 and 3. So 2 times 2 times 2 times 2 times 3. 16 times, yeah, 16 times 3, that's right. Because it's square root, this is going to pop out, this is going to pop out. That's going to give me 2 times 2 square root 3, or 4 square root 3. And that's going to go in for our square root 48. So I get 5 over 4 times 4 square root 3. Well, 5 over 4, again, if this is over 1, these 4s will cancel. That'll just leave me with 5 square root 3. We're going to combine that one. And then 1/2 times square root 50. Well, 50 breaks down into 2 and 25. And I think that might be where I stop because I know this is a perfect square. So this is going to be 5 square root 2. So this is going to be 1/2 times 5 square root 2, which is going to be 5 over 2 square root 2. Find those. Now, let me write this out first, and then I'll talk about it for a second. -30 square root 3 plus 3 over 2 square root 2 minus, I think it was, 5 square root 3 plus 5 over 2 square root 2. Now you can see a couple of these. 2 of them are root 3s and 2 of them are root 2s. Obviously, we can't combine the root 2s with the root 3s, but we can combine the root 3s with the root 3s and the root 2s with the root 2s. That's no different than when we have equations that simplify our expressions, that it simplified to 3x plus 4y. That's okay to leave that there because those don't combine. We do the same process for radicals. So I'm going to combine this cube root 3 or square root 3 with this square root 3. So negative 30 minus 5 is a negative 35 square root 3. And then I'm going to combine a different color. I'm going to combine 3 over 2 square root 2 plus 5 over 2 square root 2. When we're adding fractions, remember the denominators need to be the same. So we add those two together. 5 plus 3 is going to be 8. So this would be plus 8 over 2 square root 2. And 8 over 2 square root 2 simplifies to 4 square root 2. Negative 35 square root 3 plus 4 square root 2. Final answer. So I'm going to save question B. I'm going to save question B, example 2. This is going to be my in-class example. Whoops. This is going to be my in-class example that we do on the day whenever we have a Zoom to cover this lesson. Okay. Now that leaves us with example 3 on the backside or the next page. I don't know if it's the backside or the next page for you, but I had to flip my paper. Example 3, find the length of x. Find the length of x as an exact value, which means no decimals. Okay, no decimals. And as a decimal to the nearest tenth. So exact values generally mean leave your answer as a radical. Generally, but they don't want any decimals. Okay? So we need to find the length of x. Find the length of x. Well, x is this part. Right? Whoops, don't want to erase this part right here. So if I need to find that length, basically it's going to be the full length, take away this little piece. Right? So I'm going to take the full length and I'm going to subtract the little piece. But before I even write this out, I'm looking a little bit ahead. I can see this needs to be simplified. This needs to be simplified. This needs to be simplified. So before I even work ahead, I'm going to simplify each of those radicals. Okay? Maybe it'll even give us a nice simple radical to deal with instead of 2 terms. That would be the hope. So 8 square root 2 plus 2 square root 12. Well, 12 breaks down into 2 times 6, which is 2 times 3. That's a 2. So this is the square root of 2 times 3, which is 2 root 3. That's just for the 12. So 8 square root 2 plus 2 times 2 root 3 is 8 square root 2 plus 4 square root 3. That's my expression that I'm going to start with. 5 square root 27. 27 I know is 3 times 3 times 3. So this is 5 square root 3 times 3 times 3. There's a pair, it's going to pop out. It's 5 times 3, and I'm left over with my 3. That's going to give me 15 square root 3. Similar process for square root 18. I know that that's 2 times 3 times 3. So this is 3 is going to pop out. It's going to multiply to the 4 that's already there. And then that's going to leave me with a lonely square root 2 on the inside. So this is going to be minus 12 square root 2. There's my other part. Now I want to take this first part, 8 square root 2, 8 square root 2 plus 4 square root 3. And I'm going to move this down lower because I don't want it so close to that. And I want to subtract all of the other expressions. 15 square root 3 plus, no, sorry, minus 12 root 2. Now remember, when we're subtracting through a bracket like that, we need to make sure that we remember if there's no number there, that there's a 1 there that we never write, and that we need to bomb that minus 1 in. This is going to give me 8 square root 2 plus 4 square root 3 minus 15 square root 3 minus times a minus plus 12 square root 2. Now, no brackets, I can combine my like terms. 8 square root 2 plus 12 square root 2 is 20 square root 2. 4 square root 3 minus 15 square root 3 is minus 11 square root 3. Oops. And that would be our simplified, most simplified form. That's our exact value answer right there. Now the book also asks for our answer to the nearest decimal place. You take a minute and you plug that into your handy dandy calculator, which I will do. Punch that into my calculator. It says nearest tenth, I get 9.2. And I would be done. Okay, so checking Scholantis to see which questions are suggested as work to do, and we will see you next time.